Hello, everyone. I hope you're all doing well and you're feeling fine. We're looking at question 24 in this video. Pascal High School organized 3 different trips. 50% of the students went on the first trip, 80% on the second trip, and 90% of the students went on the third trip. A total of 160 students went on all 3 trips, and all of the other students went on exactly 2 trips. How many students are at Pascal High School? Ooh, okay. So this is sort of a question we could do with a counting tree or maybe a Venn diagram. Hmm. So I'm going to, just because I'm used to it a bit more, I'm going to do this with a counting tree. So I'm going to break up my students. I know I have a total of 160 students. Right? Was it 160 students? No, we don't know the total. That's the thing we're trying to find out. 160 students that went on both. So I'm going to say F is the number of students who went on the first trip, and then the people who did not go on the first trip are not F. Now, maybe you went on the first trip, maybe you went on the second trip then, or maybe you did not go on the second trip. Okay. Now, you can do this with a Venn diagram, and you might be more comfortable with Venn diagrams. We can do it with Venn diagrams in a moment. But counting trees are actually a technique we teach now in university. So, just because I've been doing counting trees for a recent class I was teaching, I figure I'll start this question off with counting trees. So the way to read this is paths from the start to the end tell a story. So this path says I'm a student who did not go on the first trip, but I went on the second trip, but I did not go on the third trip. Okay. This path says I'm a student who went on the first trip, and then the second trip, and I also went on the third trip. Okay? And the way we make a counting tree is we label numbers. So some number of students, maybe call it S for, well, no, we've got an S. Let's call it N for the number of students. Okay? Now, I know that no students went on, or sorry, all students either went on all trips, so F, then S, then T, so 160 students did that. And then there are these branches where students went on exactly 2 trips. First trip, didn't go on the second trip, but went on the third trip. And then didn't go on the first trip, but went on the next 2 trips. And nobody went on 1 trip only or no trips. So I can put zeros on these. Okay? Now, the way counting trees work is you can sort of fill in numbers as you go. And one of the main rules for counting trees is this. The numbers going into a node is equal to the sum of the numbers coming out of the node. So I've got these 2 zeros here. 0 people did not go on the first trip and did not go on the second trip. That's what we're saying here. Okay. Now, what was it? Half the students, 50% went on the first trip. So a half n goes here. That means the other half n goes down here because these numbers need to add up to n. But 0 plus something has to add up to a half n, so this is also half n. And this is also a half n. Okay, you see how we're starting to fill this thing in? Now, in terms of the number of students who went on the second school trip, well, there's 2 sort of S's. Okay? This S up here is not students who went on the second trip. It's students who first went on the first trip and then went on the second trip. But together, these 2 numbers should add up to the number of students who went on the second trip, which would be 80% or 4/5 n. So in total, I need 4/5 n. Subtract off a half n, because we've already got a half n. And so we can say 8 minus 5, or 3/10 n. Okay, so 3/10 n. And then a half minus 3/10, that'll be 2/10 n. And so that'll be 2/10 n. Okay. And I know how many people went on the third trip, and so that should be the sum of the numbers in front of the t. So 160 plus 2/10 n plus 1/2 n should be, how many students went on the third trip? 90% of the school, so that should be 9/10. Well, I'll change the half to 5/10. Okay. And then, well, 2/10 plus 5/10 is 7/10. Subtract that from both sides. I see 160 students is 2/10 n, or 1/5 n. So I'll multiply both sides by 5. We'll see we've got 800 students for n. And there we go. So we got 800 students, and we can actually see how well this works by making the full tree. Now, I am going to do it with Venn diagrams in a moment, but I wanted to show off counting trees. And counting trees are, in some situations, a bit more useful than Venn diagrams, just because Venn diagrams, if you want to have more than 3 interesting things to look at, Venn diagrams aren't the best way to do that. So a total of 800, half the students, so 400, 400, no students there, no students there, no students did that, no students did that, 400, 400, and then, oh, by the way, our answer is D, but then 3/10 and 2/10, so 2/10 times 800, so 80 times 2, so it's 160. 80 times 3, 240. 160 up here. 80 students went on the first trip, the second trip, but not on the third trip. And what was the other one? 2/10 n again, so this is a 0. And this is 160. And now we see 160 plus 160 plus 400 is 720, which is 90% of 800. 400 and 240 is 80% of 800, because that adds up to 640. So there we go. We got our answer of 80, but now we could answer anything. For example, 80 students went on the first and second trips, but not on the third trip. Okay. So that's how you do it with counting trees. Maybe you're not so comfortable with counting trees, you're not familiar with them. Let's do it with Venn diagrams, which I believe is how the official contest solutions do it. I just wanted to show something else off. If you're interested in counting trees, feel free to learn more about them. You know their name now. So let's do it with Venn diagrams. Let's do sort of some intersections with Venn diagrams. So the first trip is represented by this circle, second trip, third trip. And then we've got, of course, the people who went on no trips. So no people went on any trips. No people went on just a single trip. So the people are in just these areas here. Now we know 160 people went on all the trips. Okay. And then, well, we've got this amount, and this amount. And we can get sort of a series of equations. So the number of people who went on the first trip, we know that that's a half of what we're calling n. We can see that's A plus B plus 160. That's what's inside the F circle. And we know 80%, or 4/5 n, the total number of people in the school, is the number of people inside the S circle. So that's A plus C plus 160. And then the number inside the T circle is the number of people who went on the third school trip. That's 9/10 of the total school. That's B plus C plus 160. Okay. So what can we do from here? Well, a great way to approach something like this is to add it all up. Okay. We get 2 A's. Sorry, I'll make the universal box a little bit smaller. So on this side, we get a half plus 4/5. So I'm just going to change these to over 10s. So 5/10, 8/10. So 5 plus 8 plus 9, that's 22/10. N is 2 A's, 2 B's, 2 C's, and then a whole bunch of 160s, 3 of them, so 480. And you say, great, now I've got even more numbers to work with. But you have to remember the total number of students, period, is A plus B plus C plus the 160 in common to everything. So I know N is A plus B plus C plus 160. And if I double that, make it 20 over 10N, I get 2A, 2B, 2C, and then twice 160 is 320. And if I subtract, I get 2/10 N over here. A's, the B's, the C's cancel out. 480 minus 320 is 160. I seem to recall us working that out earlier. We had that when we did it with the counting tree. But maybe you're a bit more comfortable with Venn diagrams, and that's okay too. But we still get N is 800 there. 800 people in Pascal High School, and that's an answer of D. Okay, so a couple ways to approach it, counting trees, Venn diagrams. If you have a third different way to do it, please let me know or let everyone know by giving us a little comment down below. But there we go, 2 different ways, and we're going to move on to question 25 and wrap up our Pascal paper in the next video.